Hello Info-Person, this is Anton, and today we're going to discuss a major scientific discovery when it comes to various planets in the Milky Way. Because here we have a major breakthrough when it comes to rogue planets. For the first time ever, scientists have successfully measured the mass, the distance, and the type of a rogue planet somewhere out there by observing it from several telescopes in different locations and by essentially being able to triangulate its position, which allowed them to discover exactly what this is and where in the Milky Way it's located. And here this is actually a really exciting discovery because it was achieved by using a very bizarre Einsteinian effect that you obviously see in this simulation. This is a gravitational lensing effect that was produced by a relatively small object as it passed in front of a distant star. And so here we have this really exciting new discovery of a very mysterious world that does not orbit any star. And so let's talk about this in a bit more detail, but first let's discuss this concept of rogue planets or free-floating planets as they're also known, because this is actually kind of important when it comes to astronomy. And that's because unlike typical planets that we usually imagine orbiting a star, here there's actually a massive population of objects referred to as free-floating planets or FFPs that drift through the Milky Way without any host star or any other object in their orbit. But I guess what's even more exciting is that based on modern estimates, researchers believe there are billions if not trillions of these objects out there, with most of them very likely outnumbering typical stars by at least 10 times. And that's because based on modern simulations and based on what we know about planetary formation, we expect most stars to basically lose a few planets here and there, and some planets can form completely by themselves without the help of any star. As a matter of fact, some of the more recent observations from the James Webb confirm the existence of dozens and dozens of these jumbos or Jupiter mass objects in the famous Orion Nebula. Which means that quite a lot of them exist all over the place, and quite a lot of them can form by themselves without anyone else's help. But obviously the challenge is finding them. And that's because they're obviously really small and do not emit a lot of light, unlike a typical star or even unlike a typical brown dwarf. So most of them are incredibly dark and difficult to spot. And though most of them do produce some infrared light and do become visible with the infrared telescopes such as the James Webb, for many years discovering them was still a bit of a challenge, especially at faraway distances. But quite a few of them have been discovered in many different locations around us. Although intriguingly, when it comes to detecting these objects far away from us, right now there is really only one method: gravitational lensing, and specifically gravitational microlensing, that involves a planet passing in front of a distant star and then making the starlight suddenly brighten for anywhere from a few days to sometimes a few months. Here this usually depends on what type of an object this is and how far away from us all of this is happening. And in the last few decades, quite a few such objects have been discovered, especially by the project known as OGLE. The project that was started by the University of Warsaw back in 1992. This is the optical gravitational lensing experiment. And the experiment itself is pretty simple. Basically look at as many stars as possible, trying to find stars that suddenly brighten as something passes in front of them and basically causes them to create a gravitational lens. And so here the passing planet acts as a kind of a natural magnifying glass. This usually results in a very specific temporary spike that resembles something like this. But despite detecting these for several decades now, there's always been this one major problem with this particular phenomenon. We basically have no idea how far away this is happening. In science, this is known as mass distance degeneracy. And basically the idea here is simple. When we see this flash of light, we actually cannot tell if this was a small planet very close to us or a much larger object very far away, because they both technically produce extremely similar observations. And so without knowing the exact distance, we cannot measure the actual mass, and we have no idea exactly what created this and what passed in front of a star. So for example, it could be a slow-moving tiny planet very close to us, actually as small as planet Earth, or it can even be a really massive object, but moving very fast, close to that distant star. And so for many decades, every time these objects have been detected, their mass and their type was always a kind of a guesstimate. So we don't really know what's causing the effect, we just know that it's something that has at least some mass. And that's until this major breakthrough that happened on May 3rd, 2024. This is based on the study you can find in the description that was just released. And so here this once again was a gravitational lens. It was designated as KMT 2024 BLG 0792, or OGLE 2024 BLG 0516, mostly because it was observed by two separate telescopes in two separate countries. And the reason this event was so unique and so special was because it was captured simultaneously by both ground telescopes and a space telescope that was at least 1.5 million kilometers away from the planet. And here we're talking about the famous Gaia telescope. And this was super important, because here this event was detected at different timescales. The Gaia detection happened approximately 1.9 hours after the initial detection, suggesting that we can now use the famous parallax effect. Or in other words, we now had two completely different vantage points. We had the observations from Gaia, and we had the observations from Earth. In astronomy, this is known as the microlens parallax. And so that's kind of like, I guess, using depth perception to try to discover exactly where this object is. And so because Gaia was in a different location and its some magnification peak after nearly 2 hours, this very tiny time shift allowed the scientists to triangulate the planet's position. Here's the exact image and the exact calculations from the study. And that was enough to determine precisely what caused the effect. And while the results were quite remarkable, for the first time ever, we now have an extremely accurate confirmation of the mass for a newly discovered rogue planet. And here it's exactly 0.219 Jupiter masses, or essentially extremely close to the mass of Saturn. And this was at a distance of almost exactly 9,785 light years away from us, mostly toward the direction of the Milky Way center. And based on the observations and the calculations, it looks like this is a typical gas giant object, but it's not clear if this is a rogue planet or is a planet in orbit around a different star, but in this case with an extremely wide orbit. But since so far no additional stars have been discovered in this region, it does look like this is just a typical rogue planet. A planet that was possibly kicked out from other star systems, or might have started like one of those jumbos in the Orion belt. But this discovery also has another significance, and that's because this object falls into what astronomers refer to as Einstein's desert, or essentially a kind of a gap in observations where we actually never found any objects with these very specific lensing sizes. But by finding a Saturn mass object right in the middle of this desert, it definitively helps us understand that rogue planets are not just tiny rocky planets or giant Jupiters, but do seem to have an extremely wide spectrum of masses that we just have not captured yet. In other words, all sorts of rogue planets seem to exist, and it's just a matter of time before we discover more of them in all different sizes and masses. But why does this matter for our understanding of the universe and for general sciences? Well, first, this gives us direct evidence of an extremely violent history of various planetary systems. Because here, by analyzing its size and its mass, researchers concluded that this object is unlikely to have formed completely by itself in some kind of a nebula. Instead, it was almost certainly part of some kind of a star system, and was very likely created in a disk of gas and dust, very similar to Saturn in the solar system. But at some point, because of some kind of a gravitational interaction with a more massive planet, or possibly because of a giant star passing in the region, this object was violently ejected from its parent star and has since become a free-floating planet, which basically confirms that our galaxy very likely contains close to 1 trillion such objects traveling across everywhere, with potentially most of them being the result of these extremely violent events, and various types of active processes that seem to kick out these planets from the original star system, creating this permanent exile. But obviously this discovery is just the beginning, because we are definitely entering a completely new era of rogue planet science, especially with the upcoming Nancy Grace Roman telescope that's going to become operational in 2027. And even China's Earth 2.0 satellite, that's going to become active soon as well, will most likely help us uncover hundreds if not thousands more such objects, eventually helping us map where they're located and possibly helping us figure out where at least some of them came from. As a matter of fact, at least one of these objects possibly came from the solar system as well, as many different simulations suggested that the solar system seems to actually lack at least one planet. There might have been 9 planets a long time ago, and one seems to be missing. And so for all we know, in the next decade, we're going to discover that the galaxy is literally teeming with these objects, very likely outnumbering all of the nearby stars by at least 10 times. And by studying them and by trying to figure out how all of this happened, we're going to learn a little bit more about the stability of star systems, including the solar system, and we're also going to learn about how various materials from various nebula seem to get scattered across the galaxy as a result of this somewhat active dispersion. And so here we have a direct confirmation that the space is not really that empty. It's definitely filled with all sorts of objects, and even objects that are similar to planets like Saturn and planets like Jupiter. But before we finish this video, I also wanted to mention some of the previous really exciting discoveries from the last few years, because this is obviously not the only discovery when it comes to rogue planets. As a matter of fact, the most exciting discovery was of course from October of 2023, when James Webb Space Telescope scanned the Orion Nebula and discovered 540 planetary mass candidates. And here some of them were Saturn-sized, but some of them were much more massive, at least 13 masses of Jupiter. And this was the first official confirmation that various stellar forming regions also seem to directly form planets without the need for any star. Surprisingly, at least 40 of them seem to be in binary systems. You can learn about these objects in one of the videos in the description. Likewise, in September of 2020, for the first time ever, astronomers discovered the first terrestrial mass rogue planet that appeared to be extremely similar in mass to planet Earth. And here this object was almost certainly kicked out from some kind of a star system because it's extremely unlikely to form alone. Intriguingly, a few studies afterwards tried to see if this type of a planet can ever be habitable or at least contain conditions where some primitive life might use. With most studies concluding that, unless it has some kind of a moon, it's unlikely to be exciting. But if it does have a moon because of tidal interactions, there might be a chance for a lot of energy inside that could then create conditions necessary for simple life. Then another object referred to as CHA 11077626 was discovered to have a disk containing hydrocarbons. And specifically, this actually confirmed that some rogue planets can even have their own building blocks for various moons and basically contain their own miniature solar systems, even without having any star or any partners to interact with. And so here this was an example of a world approximately 6 masses of Jupiter forming its own miniature system. And last but not least, we have WISE 08550714. And this is our closest neighbor. This is a relatively cold rogue planet approximately 7.2 light years away from us, and is essentially one of the closest objects to the solar system. But also seems to be extremely old and might have drifted alone for an extremely long time. Intriguingly, its mass is about 3 to 10 Jupiter masses, but its temperature seems to be very close to what we find on the surface of Earth, anywhere from 220 to about 280 Kelvin, which makes it visible in the infrared light, and that's exactly how it was initially discovered. We also know that it contains methane and water vapor, and possibly even contains water ice clouds, similar to a lot of gas giants in the solar system. And though the planet itself is unlikely to be habitable, if it has moons, there's actually quite a high chance that because of tidal interactions, they might be kind of exciting. But until new telescopes become operational, or until we have additional observations from the James Webb or other telescopes, when it comes to rogue planets, at least for now, that's all we know. We'll definitely come back and discuss this topic in more detail in some of the future videos, but until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads, and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.